Hello guys, you're welcome back to my channel. In today's episode, I'm going to be taking you through production of electricity. Now, we're not going to be spending much of your time here today. The only thing I'm going to be taking you through is that how many set question on production of electricity in JAM altogether. Now, the first thing I wanted to know is that when we talk about electricity, we know that electricity simply means the flow of what? Electrons altogether. Now, electron is always flowing in a circuit, which is known as what? Electric circuit. But that electron will never flow. There must be something that will extend the flow of the electrons. Are we getting what I'm there? Now, the next thing that extends the flow of electron is what we call what? Electric cells. Electric cells. Majorly, you all know this as what? Electric battery. Now, before I jump into today's class, I'm going to what? If you are new to my channel, please don't forget to subscribe to my channel and also click on the like button to like my videos. Thank you so much. Now, what is an electric cell? Say about an electric cell. An electric cell is a cell that allows the flow of electric currents. Or let's say it's a device that allows the flow of what? Electric current through it. Now, the flow of electricity is done with the help of EMF, which is known as electromotive force. Altogether, it is this electromotive force that drifts the electron from a region of lower concentration to a region of what? From a region of higher concentration to a region of lower concentration. Altogether, will be like that. That is what. So, if electrons are drifted from a region of lower concentration, for example, in electricity, negative points is a region of lower concentration, while positive points is a region of what? Higher concentration. So electron drift from negative to positive, while current will always move in the reverse direction. Current flow from positive back to negative. That is stuff like that. So this electric cell has what we call an EMF in it. It is this EMF that drifts the electron from one point to another. Now, you see, these cells are different kinds. There are two different kinds of cells. We can have what we call the primary cell, and we have what we call the secondary cell. Now, these are the two types of cells that we can use to produce electric current. We can have a primary cell, and we can have what? A secondary cell. Now, these two types of cells are used, and questions are always set in JAM on these two types of cells. Majorly, their usage. Now, when we talk about primary cell, without wasting much of our time, what do you mean by primary cell? Primary cells are cells that cannot be what? Recharged. Altogether, majorly they are always used up in what? Process of the reaction. The chemicals are always used up. Altogether. And one thing is that these chemicals can never be what? Reverse. That is primary cell. While secondary cells are cells that can what? Be recharged. Altogether. So we can easily recharge our secondary cells. Altogether like that. That is for secondary cell. Now, what are the major examples of primary cells that we have, and what should we be expecting in JAM under this what? Primary cells? Now, we have number one. The major one is a simple what? Majorly, all primary cells are in form of what? Electrolysis. That means, we have what we call the simple electric cell, which is known as the Lagrangian cell. Lagrangian cell. Now, we have the Lagrangian cell. Lagrangian cell is the simplest of the primary cell. Altogether, now we can have the Lagrangian cell. So it consists of this. It has two electrodes and one electrolyte. Simply means in a Lagrangian cell, we have an electrode. The electrode, we have the positive electrode, and we also have the negative electrode. Now, these are the two things that is found there. Electrodes are majorly found as either a metal. Electrode can either be a metal or it is a graphite. Now, graphite is the only electrode of carbon that can be used as an electrode. Altogether, the rest that can be used as an electrodes are metals. Altogether, so in this case here, we can use the metal that can be used. We can use copper as an electrode, and you can also use zinc zinc or copper can be used as an electrode. We can also use nickel, iron can also be used as an electrode. All these can be used as an electrode. We can also use platinum. I want to get out like that. Now, how do we go about this? I said the simplest primary cells are the Lagrangian cell. and it consists of two electrodes and then an electrolyte altogether. Now, these Michelangelo cells are of two types. Now, the major type of this Michelangelo cell that we have what we call the wet type and the dry type. We have the wet Michelangelo cell and the dry Michelangelo cell. But the major problem is that what are the major questions that we ask on this? I want you to jot down something. One of the major questions that we ask on this is what kind of electrodes are used for these two types of what cells altogether, and what is the electrolyte that is found in this what cells altogether. Now, for any Michelangelo cell has two electrodes. The first electrode that is there is carbon. Carbon rod is serving as an electrode, and it also has what? A zinc. Zinc as the electrode, and the electrode. Now you said we have electrode and the electrolytes. Have you? So the electrolyte that is used in the Michelangelo cell is ammonium chloride. Ammonium chloride. This is the electrolyte that is used in what? Any Michelangelo cell. Let's take it as what? NH4Cl. Now, ammonium chloride is used in what? Michelangelo cell. Now, we can have these three things in this what? Michelangelo cell. Now, let's not categorize them. If I have a wet type Michelangelo cell, a wet type look like this. Altogether, in a wet type, the electrolyte, which is ammonium chloride, is in form of solution in a wet type Michelangelo cell, while the zinc is serving the zinc and the carbon rod. Both of them are like what? Rod. That two electrodes are in form of what? Rods. Altogether. But for a dry type Michelangelo cell, it is in a different case. For dry type Michelangelo cell, the carbon rod is serving as the anode. The carbon is anode. We have anode as the carbon, while zinc, is used as the what? Cathode. Please take note of this. Anode, the carbon rod is serving as the anode, and the zinc rod is serving as what? Cathode. Are you getting me? In a what? Michelangelo cell, both for wet and dry, but their usage are different. For wet type, it is always like this. Altogether, the anode and what? Cathode. Now, take note of something again. In any cell, electricity is always entering an electrolyte through the anode, and it is going to leak the electrolyte through the what? Cathode. Electricity, this is the electrolyte. The solution that is there is the electrolyte. Now, electricity will enter into the what? Electrolyte through the what? Anode, and it will leave the electrolyte through the what? Cathode. I want to get out like that. That is that for that. Now, let's see this dry Michelangelo cell. The dry Michelangelo cell itself also has a carbon rod, but it has a carbon rod as what? Anode. But its own zinc is not like rod like this. In this dry cell, the zinc is the plates. Look up. The plates of the electrolyte is being found is taken as the what? Zinc plates. Altogether, while the rod inside of it here is the carbon rod. So the carbon rod here is the anode, while the plate, the container, is made of zinc, which is the cathode. Altogether, now inside of it here, we now have what we call the what? The electrolyte, which is ammonium chloride. But for a dry one, the electrolyte is not in solution as the wet one. The electrolyte is in form of what? Molten state, which is a paste. It's in form of a paste. So in this one here, the electrolyte is in form of a paste, while in this one here, the electrolyte is in form of what? A solution. Altogether will be like that. Now that is that for that. Now you now see one of the major things about this primary cell. Why we don't use it again? Why we don't use it again? When we want to move on to a secondary school. Now, Jam will be asking a question about defeats of this kind of cells. Now, all primary cells has what? Defeats in them. That's why they can never, because of these defeats that they have, that's why we cannot recharge with primary cell altogether. Now, what are the defeats that primary cells can have? The first one, we can have what we call the what? There are two different types of what? Defeats of what? Simple cells. Altogether, we have two different types of what? Defeats. The first one is what we call polarization. And the second one is what we call local action. Now, these two are the defeats of simple cells. we have polarizations, and we also have what? Local action. Now, what is by polarization? I think I saw a question in JAM whereby they said polarization is a defect that is caused by what? Are you getting something now? Now, polarization is always caused by what? Deposition of hydrogen bubble on the anode in a simple cell. That's what causes polarization. Are you getting something now? Let me show you something. In electrolysis, if assuming I use H2SO4 as the electrolyte, if H2SO4 is as well, this is as the electrolyte. If current is passed through the solution, there is something that will occur. What is it? This H2SO4 is going to dissociate. When it dissociates, it's going to produce hydrogen ion plus sulfate ion. Altogether, normally in electrolysis, it is meant to be like this. The hydrogen ion, which is the positive ion, should move to where? The negative electrode. While the sulfate ion, which is the negative ion, should move to the where? Positive electrode. Are you getting something now? Now, the reverse is not the case. Are you getting something now? Now, what causes majorly the effect? And one thing about polarization is that what? It kills the cell. It reduces what? The lifespan of the cell. Are you getting it? After some time, the cell will be slow to produce because of the action of what? Polarization. So when I say polarization, it simply means deposition of hydrogen. Are you getting it? Hydrogen bubbles on the anode of any cell. Now, what is the anode of this cell? The anode of this cell is carbon. Are you getting something now? Which is the anode? You know, I said the cathode is made of zinc. Why the anode is made of what? Carbon. But what kind of carbon? You know, we don't call graphite. They will not call it graphite, but here they are referring to what? Graphite. Because carbon, whenever they say carbon, they are referring to graphite. Right? Because it can be of diamond or graphite. But the one that can be used to conduct electricity is what? Graphite, not diamond. Now, in this case here now, I said something about the polarization. So when hydrogen bubbles are formulated on this anode, it causes the effect of what? Polarization. Now, another question they will now ask you that what? How can we reduce the effect of polarization? Or you get something now? How can we reduce it in a cell? Now, effect of polarization can be reduced by using a depolarizer. Now, the function of the polarizer is going to produce hydrogen bubbles on the surface. Then the function of the depolarizer is to prevent, just like a coating. Now, we can have a coating on the surface, like for example now, if I have a metal, normally it is metal is going to rust when it got to a kind of environment like water, environment or air. All metal like iron, they are going to rust. That rust that you are seeing in metal, it is because that metal is reacting with air or it is reacting with water. From our forms, it will form a surface like something like a reddish on the surface like this. It is known as iron 2 oxide. Iron 2 oxide will form on the surface, which is known as rust. Are you getting it? Now, we can prevent this rust of iron either by painting it. If you paint iron, what is the function of the paint? The function of the paint is to prevent rusting to take place. But it doesn't mean that rusting might not take place after some time. Are you getting something now? The same thing applies to polarization. In polarization, we can easily prevent the rod, the anode, from what? Deposition of hydrogen bubbles. So the only way we can use to prevent it is by adding a what? A depolarizer to the anode. All together. Now, what are the major examples of depolarizer we normally use in a primary cell? We make use of what? Manganese 4 oxide is used as a what? Depolarizer. All together. So manganese 4 oxide is serving as depolarizer in the clanchel cell. All together like that. We make use of what? Manganese 4 oxide. Now, the function of this depolarizer is to prevent the cell. Are you getting what I'm saying now? Now, that is the first effect. Now, okay, another way, because you might not see manganese 4 oxide in the option, there's another way of what? Preventing polarization to occur. One of the major ways is by what? Brushing the plates. Brushing of the plates. That's another way. If you are brushing the plates, it can also prevent. Normally, the hydrogen bubble are already on the surface of the rod. So we will remove the rod, then brush it. On brushing it, it will remove all the hydrogen bubbles that are there. That's another way of producing to prevent polarization to occur. So whenever you hear polarization, know that it is talking about what? Hydrogen. Now the second one is now local action. Local action is an effect, of a simple cell that is caused by the usage of an impure zinc. Normally, I said in a cancer cell, zinc can be used as what? Cathode. Are you getting what I'm saying now? Now, if the zinc that is used is an impure. Now, impure zinc are zinc that has some oxide on the surface. Are you getting what I'm saying now? So, if an impure zinc is used as the cathode, then it's going to cause an effect of what? Local action. Are you getting what I'm doing like that? That is going to cause what? An effect of what? Local. And that local action simply means the wearing away. Normally the zinc is impure. So when it gets into the solution, it started to wear. Wear simply means to eat off. Are you getting me? Now it will be eaten off and be coming into the electrolytes. So it will cause wearing away of the zinc plates. So this thing can easily be prevented. We can prevent local action by washing the surface of the zinc with what? H2SO4. Now, local action can be prevented using what? H2SO4 to wash the surface, while polarization can be prevented using a depolarizer, manganese 4 oxide, MnO2, or by brushing the plate. It can be used to prevent polarization, and local action by what? The usage of H2SO4 to wash the water surface. All together. Now, see, many cells are produced. Many cells have been produced to reduce the effect of this. To reduce this effect. One of the major cells that is produced to prevent these cells, to prevent hydrogen polarization and local action, is what we call a Daniel cell. Daniel. Now, the major thing is that what differentiates this Daniel cell from other kinds of cells that we have? That's what we want to know. Now you see, in Daniel cells, it uses the same electrode altogether. We have its own positive electrode and its what? Negative electrode altogether like that. Now its own positive, its own anode. In this one here, the anode is made up of what? Graphite, which is carbon, But for its own anode is made up of copper. In Daniel cell, the anode is made up of copper. Are you getting it? And the electrolyte that is there is of what? 2SO4. That is electron surface 6 acid. So the 6 acid is used as what? Electrolytes. And also, in this case here, we make use of in a cathode, in a Daniel cell. The cathode is made up of zinc rod, while the anode is made up of copper rod. Now, the electrolyte is now made up of H2SO4, which is acidified what? Because of a 6 acid. Now, I said one of the major reasons that it can be used to prevent this polarization is by using the depolarizer. Now, in the cancer cell, we make use of manganese 4 oxide as depolarizer, but in a Daniel cell, which is used to prevent the food thing, copper sulfate is used as the depolarizer altogether. So if they ask you that which of the following cells prevent polarization completely altogether, it is Daniel cells. Are you getting something now? So it makes use of copper sulfate as its own depolarizer and makes use of all these electrolytes, anode and what? Cathode. Now that is that for that. Now you let's see the second type of cell that now is now the secondary cells. The secondary cells are cells that can be rechargeable. You can recharge secondary cell. Now I think I saw a question in JAM whereby they ask them, the only thing they want to ask you about these cells is what is the cathode and what is made as the anode. The next thing is that what is the electrolyte that is used in the cell? Are you getting what I'm saying now? Now, let's think carefully. Now, for the secondary cells, there are 2 types. Now, the secondary cells are cells. Are you getting me? That can be recharged after it has been used. Are you getting what I'm saying now? Now, we can have okay. Now, we can have can use one lead acid accumulator, and number 2, we can use alkaline accumulator. Now we can use what? Lead acid accumulator, and we can also use an alkaline accumulator. Now these are the 2 major types of secondary cells that we have. Please take notes. Now these are the 2 major types of secondary. Now please take note of something. You see, these 2 effects of cells does not affect secondary cells. It can only affect the primary cells. That's why one of the major reasons why primary cell can only be used once. The only way you can use them again is by what? Changing the electrodes and the electrolyte completely. That means once we use them, we need to remove the carbon rod, replace another new one. Then the electrolyte should also be replaced with another new one. But these ones are not like that. Secondary cells can be recharged. But you get what I'm saying now? Now, what are the major things that are found in secondary cells? We'll talk about their anode and what? Cathode, and the electrolytes that can be used. Electrolytes that is used. Now, for the anode, in lead acid accumulator, lead is used as the anode, while the cathode is made of lead oxide. Lead oxide. Lead oxide is used as what? Anode, while lead is used as a cathode. While the electrolytes is made of H2SO4. That's what we use to what? Do the electrolytes, H2SO4, which is tetrasulfate 6 acid. Now, anode is lead oxide, the cathode is made of what? Lead, and the electrolyte is made of what? H2SO4. Now, while for alkaline accumulator, it is different. The anode is made of cadmium, and we can also use what? Iron as the anode. Iron, cadmium or what? Iron. While the cathode is made of nickel oxide, we can nickel hydroxide. We can use potassium hydroxide. We can use what? Nickel oxide as what? And cathode. Cathode we make of what? Nickel oxide as was cathode. Why the electrolytes that is there? The electrolytes that is here, we can use potassium hydroxide that is being dissolved in water. Now, potassium hydroxide that is dissolved in water, KOA. When you dissolve potassium hydroxide in water, it can be used as its own electrolyte. But the problem that is there is that what? Major questions are not much on this in JAM. The only one I've seen so far is the usage of the alkaline lead acid accumulator, and they only ask about the one that we use as the anode, and what can we use as a cathode. So the cathode is made of the metal itself. Are you getting it? Why the anode are made of what? Oxide of the metals all together. So oxide of the metal and the cathode is what? The metal. Then we can use any one. This one here is an acidified tetrasulfate 6 acid. Are you getting it? Normally in the electrolysis of water. So this is always used for the electrolysis of water. So my major question now is if you have to study for this topic for JAM, just major yourself on the effect of what simple cells. Why? Because there is not much questions on what secondary cells compared to what primary cells. Now let's take up some questions on these two cells to just round up my class for today. Now, I think I saw I'm taking only 3 questions here. Now for the first question, we said the EMF of a freshly charged Leclanché cells is what? I think I will mix that. Now, a Leclanché cell, if a Leclanché cell is what? Made at the first instance, are you getting what I'm saying? It has an EMF of 1.5 volts. That is the EMF of what? Leclanché cell. Example of this Leclanché cell is your normal battery. Your normal battery is an example of a Leclanché cell. So when you charge it, when you made it the first time, it has an EMF of what? 1.5 volts. So the question said the EMF of a freshly charged differential cell is A 5.0, B 3.0, C 1.5, and D we have 1.2 volts altogether. So we have the answer to be 1.5 volts. Second question, which of the following is a depolarizer? You know, I said depolarizer is used to reduce what? Polarization. So which of the following is a depolarizer? We have manganese 4 oxide, ammonium chloride, powdered carbon, and zinc solution. Now, the reason is that for the polarizer, we can only have two types of polarizer. It is either we are using manganese 4 oxide or we are using copper sulfate. And I said manganese 4 oxide can only be used for the Lange cell, and copper sulfate is used for what? Daniel cell. In Daniel cell, we make use of copper sulfate as the polarizer, while manganese 4 oxide is used in what? In the Lange cell. Now, the third question is that they said, which of the following is not a defeat of a simple voltaic cell? Another name that we can give to a Leclanche cell, we call it a voltaic cell. All cells, both Leclanche cell and Daniel cell and your secondary cells, all of them are known as voltaic cell. Voltaic cell. Altogether, so we can have a simple voltaic cell. The simple one are the primary cells. The secondary we can have a secondary voltaic cell. So the question said, which of the following is not a defeat of a simple voltaic cell? Now, a simple voltaic cell can only have two defeats, which is polarization and local action. These are the two defeats. Also, that here we have local action, B fluctuation, C polarization, D diffraction. Diffraction is not a defeat, but it is a property of the wave. So the answer to that is what? Local action is what? Which of the following is not a defeat of a simple voltaic cell? So the one that is not a defeat of a simple voltaic cell is fluctuation. I was surprised that even in the option, diffraction can also be a defeat. But I think that is just an advanced thing. So the only one that cannot be a defeat is fluctuation in the option, fluctuation. So I think that is that for that. Thank you for watching this video. Please don't forget to subscribe to my channel and also click on the like button. You can also share with your friends. Thank you so much.